Hi everyone, myself Syam Sundar. In this video, I am going to explain about searching techniques in C language. There are two types of searching techniques. They are linear search and binary search. Let's watch them carefully. Linear search. It is the simple searching technique in C language. Linear search is applicable for both sorted and unsorted arrays. Linear search is nothing but we'll compare each and every element of array from starting of array to end of array. If the element is found at some location, then we'll print that location. If the element is not found, then we'll print that element is not found in the array. We'll do all this process by using simply a for loop. To understand the linear search, let's take this example. Let us consider an array of size 6 whose index starts from 0 and ends at 5. I am taking some random elements 6, 15, 25, 36, 42 and 47. Suppose I want to search for 36. Now we'll start from starting of the array. A of 0. A of 0 is nothing but 6. Since our key is not equals to A of 0, then we'll move to next location, A of 1. A of 1, it is 15. So it is not equal to 36. So we'll move to next location, A of 2. It is 25. Since 25 is not equal to 36, we will move to next location, 36. Since 36 is equal to 36, therefore our required element key is equals to A of 3. So we will print that the element is found at the location 3. So like this, the linear search will work. So to find our required key element, we are using 0 to n. So the time complexity of the linear search is big O of n. So to find our key element, we are using all the elements of the array, n elements. So the time complexity of the linear search program is big O of n. Binary search. Binary search is slightly complex as compared to that of linear search. And binary search is only applicable for sorted arrays. It is only applicable for sorted arrays. To understand binary search, let us consider an array of size 11. So the index starts from 0, 1, 2, and so on, 10. Here we will use mid variable to calculate our required key element, where mid value will come from low and high variables. We will consider the 0th index starting element as low index and the last element, final element as high. Low index is 0 and high is 10 here. So while low is less than or equal to high, the mid value will come from average of low and high values. So the mid value is mid equal to low plus high by 2. just we are using indices, not the values. So by using this mid variable, this mid value, we are going to find our required key element. Definitely our required element will be present from low to high if the element is present in the array. Otherwise, at last we will print that the required element, key element, is not present in the array. So how it works means, we will consider three cases. The element may be present from low value to mid or mid to high, otherwise exactly at the mid position. So if our required element key is present from low to mid, means if the key is less than a of mid, we will change the high index as mid minus 1, means we will search from here to here. That is our motto. So if the key is less than a of mid, we will change the high index as mid minus 1 here, means we will search from here to here. Then our required element will be come out. Otherwise, if our required element is greater than mid, means if the key is greater than a of mid, means it will be present somewhere from here to here. So for that purpose, we will change low value as low index as mid plus 1, low as mid plus 1, means we will search from here to here. Definitely it will be somewhere from here to here. Then the last condition is what? Our required element is present exactly at the mid location. Means if our required element is present at the mid location, then directly we will print our required element key is found at the mid location. We will use break statement for the duplicate elements. Means if already here 20 is there, if somewhere in the array next time if 20 repeats, the first time where the 20 is present, at that position only will print and will break. Let us consider this example to understand the binary search. Let us consider this array where the size of the array is 11. Here we are taking some random elements 6, 14, 20, 27, 31, 36, 44, 47, 55, 68, 77. Hence binary search works only on sorted arrays. So we are taking assignment order, means ascending order, where the elements is increasing from low to high. Since it is sorted array, we can use the binary search here. Suppose I am going to search for 55. Our required key element is 55. Here low value is 0 and high value is 10. Since low is less than high, 0 is less than 10, our mid value will be 0 plus 10 by 2. Mid value becomes 5, where mid is here. Since our required element key is 55, which is greater than a of mid, So now we have to change the low value as mid plus 1. So the low value becomes mid plus 1, which is 6. Now the low value is 6 and high value is 10. Since low is less than high, because 6 is less than 10, again the now mid variable becomes 6 plus 10 by 2, which is nothing but 8. Now the mid becomes 8. Again we'll search for key. Our key is 55, which is exactly at the mid position. So since our key is equals to a of mid, so we'll print the statement that the element is found at the location mid, which is at a of 8. So it will print mid location, 8 location, and the break statement executes. It will come out of the program. So to find the key value, every time we are making our array into half. Again we are making our array into half size. So the time complexity of this binary search is big O of log n base 2. That's about the linear search and binary search. Please kindly like the video and share to your friends. Until then, bye bye.